All right, so your API is passing all its functional tests. You're feeling good, ready to ship it, but hold on a second. Are you still just clicking around manually to see if it feels fast enough? Come on, let's be real. You've got that nagging voice in the back of your head, right? What happens when 1,000, 10,000 users all hit this thing at the exact same time?
Yeah, that right there, that's what we call the performance blind spot. It's this massive, terrifying gap between, hey, it works on my machine, and oh, wow, it can actually handle the Black Friday rush. Just pushing code out and hoping for the best. Well, that's not a strategy. It's pretty much a recipe for a very, very bad day at the office.
So let's just ask the question we're all thinking. Is your API really ready for prime time? I mean, can it actually handle that huge traffic spike when marketing finally launches their big campaign? Or is it just going to curl up into a ball and completely fall over? Look, the old way of doing things is pure guesswork. You click a few buttons, you refresh the page, and you just hope it holds up. But the smart way, the professional way, is to swap out that hope for cold, hard data. We're talking about real metrics, things like latency, throughput, and error rates, so you know, without a shadow of a doubt, exactly what your API is capable of. Okay, to really wrap our heads around this, I want you to do something for me. Just for a minute, forget about code, forget about APIs. From this point forward, you're a bridge engineer. Seriously, just trust me on this one. This one little mental shift is going to make everything click into place. Think about it. You would never, ever build a giant new bridge and then just let one single car drive across it and say, yep, it's good to go. Open it up. No way. You'd run simulations, you'd send thousands of cars over it, you'd push it to its absolute limits to find out where it starts to shake. And that is exactly what performance testing is for our API. So let's talk about our bridge metrics. First up, latency. In our bridge world, latency is simply the time it takes for a single car to get from one end to the other. In the API world, it's the delay between sending a request and getting that very first byte of the response back. It's all about how responsive the system feels. And then we have throughput. For our bridge, this is its total capacity. How many cars can we get across this thing every minute? For our API, it's the same idea. How many requests can it successfully handle in a given period of time? This is all about raw power and efficiency. Okay, so how do we actually become these API bridge engineers? Well, we need a tool to simulate all that traffic. And the go-to for this is a fantastic open source tool called Apache JMeter. Let's fire it up and walk through how you can build your very first load test, step by step. The whole process is actually pretty straightforward. It boils down to 3 steps. First, you've got to define your objectives. What does good enough actually look like? Second, you configure your load using something called a thread group. That's just JMeter speak for your virtual users. And finally, you hit go and analyze the results to see what, if anything, catches fire. So the real heart of your test plan is this thread group. This is where you tell JMeter how to simulate your users. You've got 3 key settings here. Number of threads is just a fancy way of saying how many virtual users. Ramp up period is how long it takes for all those users to start hitting your API. And duration is, well, it's how long the test runs. Pretty simple, right? Now, here's something really cool about JMeter. Everything you just configured in that nice GUI, it all gets saved as a plain old XML file. And why is that awesome? Because it means you can treat your performance tests just like code. You can check them into Git, you can version them, and most importantly, you can plug them directly into your CI/CD pipeline. This is huge. But listen, just measuring this stuff isn't the whole story. You need a line in the sand, a quality gate. That's where something called an assertion comes in. It's super powerful. You're basically telling JMeter, hey, if any single response takes longer than, say, 500 milliseconds, I want you to fail the whole test. Stop the build. This is how you automatically enforce your performance standards, your service level agreements, or SLAs. Okay, getting started is one thing, but there are a couple of classic rookie mistakes that trip up almost everyone when they're new to this. So let's go over them right now so you can sidestep all that pain. Think of this as a little insider info to get you up to speed fast. All right, mistake number 1, and this is a big one. Never run a real load test from the JMeter GUI. Seriously, just don't. It's a huge memory hog and it'll mess up your results. Number 2, trying to use a functional testing tool like Postman in a for loop. It's just not designed for that. It doesn't create true concurrent load. And the third mistake, probably the most common, is forgetting to add assertions. Without them, you're not really testing anything. You're just watching numbers go by. It's observation, not validation.
Okay, so you've dodged the common pitfalls. Fantastic. Now, let's talk about what separates the pros from the rookies. Here are a few insider tips from the top 1% of QA engineers that will take your performance testing from good to absolutely essential. This is how you really level up.
Pro tip number 1, always run your tests in headless mode. That means from the command line with no GUI. That's the only way to get truly accurate numbers. 2, automate everything. Get these tests running in your CI/CD pipeline so that performance is checked on every single code change. And 3, don't just test for the average day. You need to simulate those crazy sudden traffic surges. That's how you find the real breaking point of your application.
Whew, we've covered a ton of ground here, right? From bridge engineers all the way to CI/CD pipelines. So let's just boil it all down. If you walk away with only 3 things from this explainer, make it these 3.
Okay, takeaway number 1, your purpose. You're here to measure latency and throughput to make sure your API doesn't crumble under pressure. Number 2, your tool. JMeter's thread group is your best friend for simulating real user traffic. And number 3, your action. You have to use assertions to create a quality gate and automatically enforce your performance goals. Seriously, master these 3 points and you're already way ahead of most people.
So, you now have the knowledge and the tools to find the performance weak spots in any API. You can see exactly where that bridge starts to sag when the traffic gets heavy. So, the big question I want to leave you with is this. Now that you can find the bottlenecks, what's your plan to fix them?